Okay, class, we are now talking on endochondral bone formation. Remember, the last one we did was intramembranous, where bone ossification occurred in a soft connective tissue. All right, before we start endochondral bone formation, which is bone formed in cartilage, let's talk a little bit about cartilage. There are three types of cartilage in the body: hyaline cartilage, elastic cartilage, and fibrocartilage. Hyaline cartilage is real smooth and creamy type looking cartilage. Okay, that's hyaline cartilage. Elastic cartilage has a lot of elastic fibers. Elastic cartilage would be an example, what's on your ear. That would be on the ear. You know how you can flip the ear back, and that's elastic cartilage. Fibrocartilage would be on your nose. You see, it's tougher. So hyaline cartilage provides support, flexibility, a lot of elastic fibers, elasticity, and fibrocartilage gives some softness, but it has good toughness. Some softness, but it has good toughness. Okay? Those are the three types of cartilage. Okay? Now, cartilage, I'm going to go back here, also was formed from this cell here, because what you come up with are what we call chondroblasts, and chondroblasts are the ones that's going to make the cartilage. Okay? Chondroblasts will make the cartilage. Okay? So we go back here, and we say, here's some areas of various types. Now, cartilage, let me go here. I missed something. Cartilage contains no blood vessels or nerves. Okay. You remember I said that bone, you had to get the blood vessels up in there. Why? Because of the fact that the calcium cuts off the air. There's no calcium on cartilage. So an area of cartilage can do good diffusion. An area of cartilage, so you don't need blood vessels up into the cartilage itself, because it can diffuse from the outside because there's no calcified. There's not a calcified matrix. Okay? All right. Here you can glance at, these are areas that you would find various types of cartilage. Here are areas you would find various types of cartilage there. Okay? Now, when it comes to growth of cartilage cells grow by appositional. When you say appositional, I want you to think about apply. Apply. That means that a cartilage cell would secrete cartilage and on the edge, and then come back and secrete another layer of cartilage. That's appositional. Now we're going to say bone growth also can be by appositional. So you're secreting by the external surface. That means, let's say that you put a layer of paint down, and then you come back and put another layer on top of that and another layer so it gets thicker. That's apposition applying. Interstitial means you're right in the middle. So interstitial would be like you are waxing a floor and you wax yourself right into the middle of the floor on a gymnasium floor. That's interstitial because you're right in the middle. Okay? So appositional means to put on the surface. Interstitial means to be within. Bone cannot do interstitial. I'm back to bone. But it can do appositional. But cartilage can do both. The reason cartilage can do interstitial and bone can't, because you can't paint yourself in with bone or it can't breathe. Now, bone cells, therefore, do not secrete all around them. Bone cells only secrete from one side. The problem is, how do they get painted in? Their brother behind them, if they secrete in the front and their brother behind them secretes in the back, then they're painted in even though the cell itself didn't do it. See? Even though the cell itself didn't do it. They painted in front. Bone cell behind them painted in front, which meant it painted in the back of the one that's in front of them. All right, something just to think about. So, the hyaline cartilage model is a prototype. Now, this is where that movie really comes in and can explain it. Okay? Requires breakdown of the cartilage prior to ossification. Two things can occupy the same space. Now, when it comes to endochondral bone formation, let me make a correction here. When it comes to endochondral bone formation, there are two ways that this will happen. Two ways this will happen when it comes to endochondral bone formation. One way is primary bone formation, and the other is secondary. So we're going to start here. Primary bone formation. Primary bone formation is making bone. Secondary bone formation is remodeling. Now this is only an endochondral. Primary bone formation is making bone. Secondary bone formation is remodeling. Primary bone formation has two processes: primary ossification and secondary. Primary ossification and secondary. Okay, let me come over here to this picture here. Primary ossification is when you start making bone in the diaphysis. Secondary ossification is when you start making bone in the epiphysis. Primary in the diaphysis, secondary. The one here occurs around the time of birth. Remember, the primary occurred around, it started around 8 weeks, and around 12 weeks, remember the time scale? Remember the time scale? And then after you make bone, you have to smooth it out and remodel it and cut the ossification centers, put the eversion canal in and everything. All right, so here's this picture here. So basically what happens, chondrocytes come in. Chondrocytes come from mesenchyme. They come in and lay down this hyaline cartilage model. Again, this is where the video would help better. They lay it down within soft tissue. Okay. So what will happen is primarily this. Before you get this bone collar, and that's what the movie would show, you get a cartilaginous collar. Instead of a bone collar, you get a perichondrium. Then once you start putting bone in, then you'll get the bone collar. Okay? Primary ossification here. So you go there, and you can kind of read on it as to how the bone-making cells enter with the blood vessels to make bone up in here. And then secondary ossification occurs here. This is shortly after birth. Around the time of birth, shall I say. Now, it's going to leave this area. So you're going to ossify here and ossify here. But here, you're going to leave that as cartilage, because that's going to be the growth plate. Now, the movie can really kind of show it in sequence. The movie can show it in sequence as to how you would go from here, 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 here. That movie that I brought up with the link. Okay, so this is looking at this bone being made. See, the blue is cartilage. Bone coming in. Blood vessels are coming in, forming the nutrient foramen, and so forth like that. Then here comes secondary ossification. But you notice we keep in blue where? Here for the growth plate, and here because hyaline cartilage forms the articular surface. So you bone every area, but you leave this as cartilage for a while. That's where you grow from. And this right here for the articular surface. Now I want you to really study that, but that movie will really do it better. Okay, so now we come to bone growth. I have even a movie for bone growth. But I want to go back and remind you, of the movie. See, these movies here, those two again, intramembranous bone formation and endochondral, can really explain better in a motion video type of mechanism rather than me. Now, if I was face to face, I could, because I could draw pictures. So I'm going to depend on your ingenuity to go back and look at this, and your in-depthness to do that, and also read the textbook, and you can get a flavoring for how this occurs. But again, you start out with a cartilage model, a prototype. It's hyaline cartilage. You come in, and then the bone starts getting worn away as the cartilage, gets worn away as osteoblasts start putting bone. Then you start doing it in the diaphysis. This is primary bone formation, primary ossification. Primary bone formation, primary ossification. Around the time of birth, you started in the epiphysis. When it's all said and done, you keep this as cartilage, which we're going to talk about the growth plate, and this is cartilage, which are the articular surface. Nice smooth surfaces. See, when that articular cartilage is worn away, that's when you have arthritis. Bone grinds against bone, because there would be another bone up there that you'd be articulating, forming a joint. Bone grinds against bone. That's what arthritis is. In particular, at least that osteoarthritis. So kind of look at this here. We've talked about cartilage a little bit. So where we are now is to talk about bone growth. So we'll end right here. Okay? Thank you.